Good day everyone, my name is Audrey Maris Giramatico and my topic is all about geological condition necessary for construction of dams, tunnels, and buildings. So what is the importance of geological condition? Geological condition helps to identify areas susceptible to failures due to geological hazards such as earthquake, landslides, weathering effects, and others. The knowledge about the geological condition is very necessary for dam, tunneling, and construction of buildings. So first is dam. Dam is an engineering structure constructed across a valley of natural depression to create a water storage reservoir. What are the three main purposes of dam? First is provision of a dependable water supply for domestic and for irrigation use. Second is flood mitigation. Third is generation of electric power. Factors affecting selection of type of dam. First is topography. Second, geological and foundation conditions. Third, availability of materials. Fourth, spillway size and location. Fifth, earthquake zone. And lastly is height of dam. Topography dictates the first choice of the type of dam. A narrow U-shaped valley, a narrow stream flowing between high rocky walls would suggest a concrete overflow dam. A low plain country would suggest an earth-filled dam with separate spillways. A narrow V-shaped valley indicates the choice of an arch dam. Geological and foundation conditions. Solid rock foundations such as granite have strong bearing power and almost every kind of dam can be built on such foundations. Gravel foundations are suitable for earthen and rock-filled dams. Silt and fine sand foundations suggest construction of earth dams or very low-gravity dams. Clay foundations are likely to cause enormous settlement of the dam. Constructions of gravity dams or rock-filled dams are not suitable on such foundations, so earthen dams after special treatment can be built. Availability of materials. In order to achieve economy in dam construction, the materials required must be available locally or at short distances from the construction site. Spillway size and location. Spillway disposes the surplus river discharge. The capacity of spillway will depend on the magnitude of the floods to be bypassed. The spillway is therefore much more important on rivers and streams with large flood potential. Earthquake zone. If dam is situated in an earthquake zone, its design must include earthquake forces. The type of structure best suited to resist earthquake shocks without danger are earthen dams and concrete gravity dams. Height of dam. Earthen dams are usually not provided for heights more than 30 meters or so. For greater heights, gravity dams are generally preferred. Second is tunnel. Tunnel may be defined as underground routes or passages driven through the ground without disturbing the overlying soil or rock cover. Tunnels are used for a wide variety of purposes. They provide essential links in many highways, railroads, and urban rapid transit systems. Tunnels can be broadly classified into the following categories based on their purpose. First is transportation tunnels. Second, utility tunnels. Third, mining tunnels. Fourth, hydroelectric power tunnels. Fifth is sewage tunnels. First is transportation tunnel. These tunnels are constructed for vehicular traffic, rail transport, and pedestrian use. Examples include road tunnels, railway tunnels, and pedestrian walkways. Second is utility tunnel. These tunnels are used to carry pipes, cables, and other utility services such as water, gas, electricity, and telecommunications. Third is mining tunnel. These tunnels are constructed in mining operations for the extraction of minerals and ores. Fourth is hydroelectric power tunnel. These tunnels are used to convey water to hydroelectric power plants where the force of the water is used to generate electricity. And lastly is sewage tunnels. These tunnels are used to transport sewage from one location to another, usually from a treatment plant to a discharge point. Tunnel construction challenges and solutions. Tunnel construction can present many challenges that need to be addressed to ensure successful completion of the project. Some of the common challenges in tunnel construction includes geotechnical conditions, groundwater, ventilation, limited space, and safety. Geotechnical conditions. The geotechnical conditions of the site can greatly affect the construction process, making it more challenging to excavate the tunnel. For example, tunnels constructed through hard rock formations are easier to excavate than those constructed through soft soil. Second is groundwater. Groundwater can pose a challenge during tunnel construction, as it can weaken the tunnel support systems and cause instability. Adequate drainage and dewatering system must be installed to prevent flooding and damage to the tunnel. Third is ventilation. Ventilation is crucial in tunnel construction to provide fresh air and remove dust, fumes, and gases that can accumulate in the tunnel. Proper ventilation is necessary for the safety of workers and the efficient operation of equipment. Fourth is limited space. The limited space in the tunnel can make it difficult to maneuver heavy equipment and materials, which can slow down the construction process. Innovative solutions such as remote-controlled equipment and robotic systems can help mitigate this challenge. Lastly is safety. Tunnel construction can be dangerous due to the risk of collapse, rockfalls, flooding, fires, and explosions. Stringent safety measures must be implemented to protect workers and the public. Building. A relatively permanent and closed construction over a plot of land, having a roof and usually windows, and often more than one level used for any of a wide variety of activities such as living, entertaining, or manufacturing. There are several geological considerations that should be taken into account when designing and constructing buildings. These include soil type and stability, second, seismic activity, third, groundwater, fourth, slope stability, and fifth is rock formations. Soil type and stability. The type of soil at the construction site and its stability are important factors to consider. Different types of soil have different properties, and some may be more prone to subsidence, liquefaction, or other types of instability. Second is seismic activity. If the construction site is in an area with seismic activity, the building should be designed to withstand earthquakes. This may involve incorporating special features such as seismic joints, base isolation, or dampers. Third is groundwater. The presence of groundwater can affect the stability of the soil and the foundation of the building. If the groundwater level is high, it may be necessary to install drainage systems or other measures to prevent water damage. Fourth is slope stability. If the construction site is on a slope, the stability of the slope must be considered. Slope stability analysis may be required to ensure that the building is not at risk of landslides or other types of slopes failure. Lastly is rock formations. The type and condition of rock formations at the construction site can affect the stability of the building foundation. If the rock is unstable or prone to erosion, special measures may need to be taken to ensure the foundations remain stable. That's all. Thank you.